So I'm going to be working through worksheet 73, which is mean and standard deviation. Start with question 1. Standard deviation. Now, a lot of you are going to be asking me about this. Standard deviation is not in our syllabus for 4th year, and therefore I won't test you on it. However, it is in 5th year, it is in 7th year. I haven't deliberately missed out 6th year, but it's... Well, it is kind of in 6th year, but it's a different type of standard deviation in 6th year. This is standard deviation with data. You can get standard deviation with something called the binomial distribution. Don't worry about it. Binomial, we look at in 7th year, so don't worry about it. Anyway, question 1. I will include standard deviation, so if you understand it, yeah, in fact, you understand it 2 years before you really need it, or 3 years before you really need it, that's okay. So, first of all, I'm going to label my column as I always do. I need to weigh 10 bags of potatoes, so let's call that weight. Oops, let's try and put weight in there. And I need to put some, okay, it's raw data, so let's put the data in. So it's going to be 5.01 kilograms, 5.03, 5.07, 5.05, 5.08, 5.04, 5.03, 5.01, 5.04, and just double check that I get all 10. That's the 10th one, okay. Calculate the mean and standard deviation of the readings. Okay, so I'll just go to add a calculator, menu, statistics, stat calculations, one variable statistics, number of lists 1, weight. No frequency list because it's just raw data, and the mean is 5.044 kilograms. Is the mean. The standard deviation is this sigma x, not the SX, but the sigma x, this little sigma x, and that's 0.024576. Doesn't matter. I'm not going to test you on that. Nigel noticed a sign on the scale saying that all the measurements are undersized by 0.02 kilograms. Explain how the effect this has on the mean and the median, the standard deviation. What it means is everything is going to be slightly heavier. Everything's going to be equivalent of 20 grams heavier, or 0.22 kilograms heavier. Now I can look at that by, oops, I don't want to go back a page. All of these I'm just going to add. So if I just go to, I call this one like corrected maybe. You don't need to do this, I'm just trying to do this to demonstrate my point. Corrected. So that's equal to, where's my equal sign here? Equals this cell plus 0.02 kilograms. Oh, try again. Plus, okay, let me plus 0.02 and click enter. I can actually fill that down. I don't know how to do that on this calculator. On yours, you just do select your cell and you do control menu, and then you click fill and you just drag and you select down. I don't know how to do a right click on this, so what I would do is this one's going to be, I'm just going to do it by hand, so I'm adding 0.02 by hand, yeah, I'm using my brain, and so on. So all of them are slightly heavier. Now can you see that that's going to affect the mean? So the mean is now going to, what are you doing? What's the calculator doing? 5.06, okay, 5.05. and 5.03 for finishing off. So they're all 20 grams heavier. Okay, so the mean is going to be 20 grams heavier. So the mean, which we had originally to be at 5.044, it's going to be at 5.064. And let's see if I'm right. So menu, statistics, stat calculations, one variable statistics, and number list 1. And this time I'm going to have a look at the corrected one, and you're going to see that the mean is now 5.064, as I say. But the standard deviation has stayed the same. Look, 0.024576 and 0.024576. They're both the same. I don't know if I can select any deep. No, I can't really. That's because standard deviation is a bit like a range. If everything changes the same amount, the range hasn't changed, or the standard deviation, the distribution, how things are moved about, hasn't changed. So it remains the same because everything's been changed by exactly the same value. So question 2. The heights of the children in year 10 were measured by results are shown below. Complete the table of the midpoint values, okay, then use them to find the mean standard deviation for the heights, given your answer to one decimal place. So can you see these are all very similar types of questions? So I'll go to add a new list in spreadsheets. This is called heights. And I'm going to plot the midpoint, so I get 100, 140, 180, 220, 260, 300, and 340. We have to have a frequency list in here, and the frequency lists are 3, 7, 20, 54, 32, and 9. Oh, okay, now I've made a mistake, so let's see what I've done. 3, 7, 20, 54, 32, 9. Okay. Oh, I know what I've done. I've gone between. Yep. Silly me. I'm really sorry. I was looking at the wrong table. I was doing question 3 for them. I was looking at the wrong one, so I need to quickly change it. I see you doing this all the time as well, so I'm glad I caught it. 135. 145, 155, 165, 175, 185. We don't have 185, so I just need to delete. That's now deleted. I go to add a calculator. I go to statistics, stat calculations, one variable. Okay, input. So that's height, okay, and I made a mistake there. I apologize. I forgot to put the frequency in. Frequency, okay, there we go. And you can see that the mean is 155.56 and the standard deviation is 10.6811. Okay, so I'm not going to do question 3. You can see how it's done. Okay, question 4. I'm going to show you how to do this. Okay, you're going to be absolutely fine with. This is question 4. I'm going to do. Okay. So I'm going to put my data in. So this is going to be my data, which is ages. Okay. So I put my data in, and what I'm going to do is I'm going to create a histogram when I've got this in. Best age there, 33, that's the best one, for obvious reasons. 29, bear with me, I'm going to do this as quickly as I possibly can. Oh, I must have made a mistake there. 48, 35. Oh, so always be careful that you get everything right. 42. Why have I've made a mistake? Oh no, okay, yeah, that's right. 42, 45, 46, 27. Okay, see, I'm making mistakes, so just be careful. So I got 46, 25, and then it's 43. After 43 was 59. 24, 37, 44. Now it's quite likely that I could have made a mistake here while typing my numbers in, and I would check it if it was an exam. But it's more of the process of how you use your calculator to do this. Now I think I've got them all because I've got all 30 numbers there. Now I'm going to put this into a histogram. So I'm going to add data and statistics. I'm going to put, okay, wait a minute, I need to go back a page. I didn't put, no I don't, because I'm absolutely fine with that. Ages is because it's raw data. Okay. Now I go to menu, plot type, histogram. I then need to go, it's going from 20 to 30, 30 to 40, 40 to 50, and so on. And then we're going to start at 20. So go plot properties, menu plot properties, histogram properties, bin settings, equal bin width, and the bin width is 10. And the alignment is we start at 20. I click enter, and I click OK. So my scale's a bit off. So I'm just making it a bit smaller. Obviously it's been an absolute pain, so I'm just going to... that's frustrating. I need to undo that, but because I moved something around. Yeah, can you see how I've changed a few bits of data here, which is really annoying. So that was 59. And that was 55, and that was 51. Okay, go back into that. It's just frustrating when it does that. Okay. And then you get your data. If you click on a data point, you've got 60, 70 had 3 points, midpoint be 65, 50 to 60 had 4 points, and so on. You can see how you use that. And then to calculate an estimate of the mean, yeah, you need to go back and you put all your frequencies and you do midpoint times all of that. I know that your calculator, you could just go to add calculator and do what we always do. One variable statistics, and oops, I need to put I'm doing this too quickly. And you get your means, but that's not an estimate. What that is, that's the exact value. You'd have to do the midpoints when it says estimate. Part C, at the Badminton Club, the mean age is 48 and the standard deviation is 8.4. Comment on the difference between these figures and those for the tennis club. So it looks to me that the mean of the tennis club is younger, and the standard deviation, which again is 12, and their standard deviation 8.4, so their standard deviation is smaller. It looks to me that the Badminton Club is older with a slightly closer, less spread, disperse age, but don't worry about that. Okay.